all of you this time, but the last 10 minutes I'm going to give chance. Okay. Today we'll try to solve textbook problems. I was talking about that we need to be expert first at the methods. Can we apply in the numerically, or can you solve the problems? First, the very basic textbook problems. So fundamental has to be very much clear here. Again, I want to give the reminder to all of you that the Fourier series is totally based on the integration. That's why if you have some doubts, if you have forgot the number of definite integration formulas, or suppose you have forgot the properties of the integration, please go through it that you can recall the formula of the integrations, property of the integrations, because this entire unit number 1 is based on only integrations. Only we have to do the integration, nothing else. Now, if I am not able to do the integrations, then I cannot solve the Fourier series. Means I cannot create a Fourier series here. Okay. It means that in my entire lectures, I assume that all of you can understand the integrations. Because in a semester 1 or 2, you have practiced lots of the integrations. In the 10+2 level also, you did the integrations. In the semester 3, we are not giving too much attention during the integrations. I assume that you have expert in the integrations. So in the last class, I have listed out some important results of the integrations. These results are going to be implemented directly. Okay, these are the results. We can do the integration directly, then we can put the answer without any calculations. Apart of this, whatever the formulas we have, it may be integration by parts, it may be integrations of different functions, and the theorems and the properties of the integrations is required here. It means that in shortcut, if I don't know integrations, then I cannot do the Fourier series. That's why those who have doubt in the integrations, please do practice the integrations. In the semester 1, I had shared one file in the WhatsApp group that these are the formula of the integrations. Please read all these integrations, and we are trying to today implement the formulas of all these integrations. Now come up here. So we can get here. If we come up here, our aim is that I want to implement today the Fourier series, the equation number 1. The equation number 1, right? The equation number 1 was our Fourier series. Okay. Equation number 1 was our Fourier series. What was the Fourier series? It was f of x is equal to a0 by 2 plus a1 cos x plus a2 cos twice x plus an cos nx plus dot dot b1 sin x plus b2 sin twice x dot dot, or it can be written in the form of summation form. How can I write in the summation form? F of x is equal to a0 by 2 plus summation n 1 to infinity an cos nx plus, okay, summation n1 to infinity bn sin nx. This was the summation form in the Fourier series. Now, what was our aim? We need to find out the value of a0. We need to find out the value of ans. We need to find out the value of bns. How to find out? The derivations is not required how it is coming, because all of us knowledge how to do the integrations. So I didn't discuss how to do the integrations. Finally, we have to note down this equation number 2. The equation number 2 is a0 is equal to 1 by 5 integration 0 to 2 is 5 f of x into dx. What is the f of x? This f of x is given to you. That find the Fourier series of the function f of x. This function is given to you in the problem solving. So equation number 2, we have to remember how to find out the a0. So last class we had discussed that what was the a0, what was the a1, b1, a2, a3, right? B2, B3. See, the calculation is different part. If I do the calculations, I can get the numbers only, right? The value of the A naught will be numbers. The value of B naught, B1, B2 will be in the numbers. But how to write the significance of this number is very much important. That's why the previous classes we have defined what is the meaning of A naught, what is the meaning of A1, B1, what is the meaning of A2, B2, and A3, B3. These signify in terms of, most of them are in terms of frequency. That's why we require all these things, okay? Then how to find out the AN? So this formula is very much important. So equation number 1 was the Fourier series. Equation number 2, how to find out the A naught. Equation number 3, how to find out the AN. Equation number 4, how to find out the BN. These are also called the coefficients of the Fourier series. Okay. Today we are trying to calculate A naught. We are trying to calculate AN. We are trying to calculate BN, and we are trying to plot some figures. And be careful that why I was talking at the beginning of the classes, some of the problem is going to be solved in the semester 4. Now, if I want to plot the Fourier series after transforming the function in the sinusoidal form, we can put how many points? Maximum 10, 15, and 50 points. But we cannot do the interpretation by considering some 30 or 20 points. So we need to do same thing in the MATLAB programming. In the computer programming, you can input a thousands number of X, then I can get a very nice graph. So this process is going to be continued in the MATLAB programming in the semester 4. Okay, so next year, to get similar formula of A naught, half has been written with A naught in the Fourier series. So sometimes the half is considered along with the formula of A naught. Some books, they don't consider A naught multiplied by half. Just look the formula here. Here, in the series, there is a A naught by 2. Some of the book, they don't mention this 1 by 2 in the first term, because they define A naught is equal to 1 by 2 directly. So don't confuse. Some books, they mention only A naught here because they define A naught is equal to 2 by 5. Okay, so don't confuse here. That's why they're talking this line here. So one example, if you do, then you can realize that how it is easy to calculate the Fourier series. If it is a textbook examples, okay, how it is easy. One student can say, if I am very much expert, if I can do the integration. If I am not able to do the integrations, then it is very difficult to the students. That's why I'm repeating number of times that please practice the integration. If I do the practice the integrations, then Fourier series you can get 100% in the textbook problem solving. But our aim is that sometime if I want to use in the real life applications, it is not too much easy. Even the semester 3, our analytic method, whatever we are solving semester 1, semester 2, and semester 3, these methods are called analytic method. Okay, what is the disadvantage of the analytic method? This method sometimes cannot solve that complex type of problem. For example, if it is a non-linear problems. Second, if the problem is very difficult, so we are not able to solve sometime. If some conditions are not satisfied, then we are not any options. We don't have any options to find out the approximate solutions. That's why a real life problem has to be solved in the semester 4, where any of the engineering problem can be solved by using the approximation method. But whatever in this particular book, whatever in any engineering book which is given in this particular semester can be solvable because they are only textbook problems. Otherwise, you may realize that why we require numerical technique. Okay, so example number 1. Find the Fourier series representing the function f of x is equal to x. Okay, f of x is equal to x. Okay, and the value of x can take from 0 to twice 5. And I think it is very simple, because to find out the value of a naught, to find out the value of an, to find out the value of bn is the simple integration, and limit is from 0 to twice 5. In this example number 1, because this is the first example, so I took very basic example, lower and upper limit also exactly 0 to twice 5. Means there is no any concept of readjustment, no concept is required of the property of the integrations, because lower and upper limit is exactly given to all of us. So this is the first part of the questions, that find the Fourier series of the given function. Okay. Second is that sketch its graph from x is equal to minus 4 phi to positive 4 phi. Means in exams also there may be questions we have to sketch the graph also. But I am talking here only 4 to 5 points. And in the real life, 4 to 5 points cannot give the accurate answer. We need to float thousands points. So that required we MATLAB sessions, means computer programming sessions are here. So as I told you that the function f of x is given to you. F of x is equal to x. It is given to you. Okay. And the x take the value 0 to twice 5. It is very strictly given to you. So we know that what was the Fourier series? Either you can write in this series form or you can write in the summation form. It is your choice. The Fourier series, we know the Fourier series, we have to write the equation number 1. This is the Fourier series, but I need to find out the value of a0. I need to find out the value of a1. I need to find out the value of a2. I need to find out the value of b1. I need to find out the value of b2. So this series can be written in the summation form. A0 by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n1 to infinity bn sin nx. So you can write either series form or you can write in terms of summation form. Thing is that in this particular example number 1, why I have written in the series form? Because I have to plot the diagram also. Okay. You may confuse that at what time I should write the sigma form, at what situation I have to write in the series form. Okay. It is different upon the questions. See, if they're asking to draw the graph, they're asking to sketch the graph, it means that ultimately I have to find out the value of f of x. I need to find out the value of f of x at the points of minus 4 phi, minus 2 phi, 0, twice phi, and 4 phi. Means I need to find out at the 5 points the value of the functions. It means that ultimately I have to expand the summation symbol. That's why I have written without summation form here. Okay. So what is our first aim? Our first aim is that to find out the value of the coefficients. What is the value of the a0? I have to find out. What is the value of the an? I have to find out. What is the value of the bn? I need to find out here. So as we know that the a0, as per the formula equation number 2, from the equation number 2, what is the a0? It is 1 by phi 0 to twice phi f of x into dx. Just put here directly formula. Why it is too much easy? Because the given function is 0 to twice phi. It is given to you. I mean, it is exactly given to you because it is the first example. So we took it is exactly given to you. It is 0 to twice phi. So just put the formula. A0 is equal to 1 phi 0 to twice phi f of x into dx. It is the formula. What is f of x? It is given to you, which is x. Put here 1 by phi 0 to twice phi x into dx. So if I do the integration, final answer is twice phi. It means that The value of the A0 is twice 5. See, I'm doing step by step example number 1 because I believe that if you can understand one single example, you can solve 1,000 examples. If you are confusion, even you are solving 500 problems, so you are not able to solve in the examination. So try to understand. So very basic. Now we have realized that to find out the A0, nothing is new. We are very much expert in the integration. I assume that we are very much expert in the integration. So we can get easily A0 is twice 5. What was the formula of the AN? AN is equal to 1 by 5 integration twice by 5 f of x into cos nx dx. This was the formula of AN. Is equal to 1 by 5, 0 to twice 5. What is f of x? F of x is x into cos nx into dx. Now, it is a product of the two functions, u and v. It means we have to do the integration by parts. And I assume that all of you are very much expert to do the integration. All of you are very much expert to do the integrations that if product of the two functions. So we are not going to discuss here in details how to do the integration by parts because I assume that all of you are very much expert how to do integration by parts. Our aim is not integration. Our aim is to construct to create the Fourier signal, to create the sinusoidal signals, functions, right? And all the requirement steps are integrations. And we believe that integration, you are expert in semester 1. Okay, those who are difficulties, please again read the integration by parts. So first function and second functions, we have to believe the method of eyelet. Okay, we have to believe the method of eyelet so we can do the integration here. How it is coming, I believe that all of you can understand. If I do the integration by force, x into cos nx is coming this. If I put the limit, the value of an is 0. Why I'm not discussing this one? I assume that all of you can do the integration by force. Okay. Now come up here in case of Bn. The formula was 1 by 5, 0 to twice 5, f of x into sine nx. Put the value of f of x, this is x sine nx dx. Now, I believe that you can also do here integration by force. It means that this is the first function, second function, or whatever it is, first or second. We believe the eyelet. T is the right eyelet. All of us know that what is the meaning of the eyelet. So I hope that you can do again this integration by force. If I do the integration by force, the value of the Bn is minus 2 by n. What is the n? What was the n? N can take the value from 1 to infinity. 1 to infinity. Because during the construction of the Fourier series, what was the Fourier series summation form? It was a0 by 2 plus summation n1 to infinity. Okay, an into cos nx plus summation n1 to infinity bn into sine nx. Okay, it means n can start from 1 only, and same thing here you can see here, n can start from 1 to infinity, 1 to infinity here. So integration by force, I assume that you can understand it. In case of Bn also, we have to do integration by parts. So I can get the value of A0 is twice 5, An is 0, and Bn is minus 2 by n here. Okay. Now, thing is that what we do here, we are doing nothing. We are just doing the integrations. That's why again I'm going to repeat, please practice the integrations. If I don't know the integrations, those who have some very basic level confusion difficulties in the integration, please let me know individually. So I have very difficulties to do the integration, then I'll provide some fundamental integration properties and theorems. In the general class, we are not going to discuss the integrations because I assume that we can do the integration here. So what I have to do in this calculation, we found that the value of the A naught is twice 5. Just put here. Okay. Put the value of A naught is twice 5. Twice 5 by 2 means 2 cancel. I can get here only 5. What is the value of AN? Means these all are 0. AN 0 means A1 also 0, A2 also 0, A3 also 0, and AN also 0. Means all these cost functions are 0, 0, 0, 0. Okay. Now what is the value of B1? See, the value of Bn is minus 2 by n. What is n? It can take 1, 2, 3, 4, 5 up to right infinity. How can I get B1? Just put n is equal to 1. So I can get B1 is minus 2. How can I get B2? Just put n is equal to 2. I can get here minus 1. How can I get the value of B3? Just put n is equal to 3. I can get minus 2 by 3. So similarly, I can get the value of B1, B2, B3, B4, B5 like this. And all the A1, A2, A3, A4, A and 0, 0 means all the cost functions are 0. Okay. Now, by putting the values, look here. What I can get? What was the left hand side? This is the f of x. See, we are just putting the value of here A naught, putting the value of A1, A2, AN, putting the value of B1, B2, B3, Bn. Left hand side is what is f of x? F of is it is x given to you. Okay, that's why it is x is equal to how it is coming. This is the value of A naught. Just put the value of A naught twice 5. 2 cancel, so I can get only 5 here. Okay, so it has become 5. It is coming the value of A naught by 2. Next, all the costs are 0, so it is not required. What was the B1? B1 is n is equal to 1. It means it is minus 2 cos sine x, minus 2 sine x. So I took the minus 2 common here because the minus 2 is going to be in all the cases are here. What was the value of B2? N is equal to 2 here. This is minus 2. So I took here minus 2 common means 1 by 2. If I multiply it, I can get minus 1. Same thing, what is the n is equal to B3? B3 means n is equal to 3. It means it is minus 2 by 3. So it is, I took minus common. So if I do multiply here to minus sine x minus 2y sine x minus sine 2y x minus 2 by 3 sine 3x like this dot. So I took the 2 common here. If I took 2 common here, I can get x is equal to 5 minus 2 common sine x plus half sine 2x plus 1 by 3 sine 3x. This is the first part. This is the first part of the equations. This series is called the Fourier series of the given function f of x. Now do one thing here. Do one thing here. What do you observe here? What was the sine and cos function? Sine function represent always a periodic function. Okay, sine functions represent always a stable signal. Okay, now if any signal it follows the sine and cosine function, it is recognized as a stable signal. It means what? The function f of x is equal to x. This was the only f of x is equal to x, and this function was the odd function. What's the meaning of odd functions? If I put the value of x, if put the value of x, the value of the function will change its sign conventions. If I change the sign convention, if I put the value of x is minus, then the f of x is suppose it is minus. If I put the value of x is plus, then value of f of x become again, it means it is changing. It means that it is a odd function. What is the even functions? If I change the sign convention of the x, the sign convention of the given functions will not be changed. This type of function is called the even functions. What is the example of the odd functions? The The example of the odd function is sine x. The example of the even function is cos x. Okay. Now, the actual given function was odd functions, and our Fourier series also become our odd functions. Okay. Some of the books, they may write this series is called the odd Fourier series. Some book, they may write this series is called the sine Fourier series. Why it is? Because in the Fourier series, there is no any cos functions. All the cos functions are become 0 because the value of an is 0. So this final answer, we observe that it is in terms of sine function. The sine function is odd function. Some of that book, they may say this is a odd Fourier series. Some books, they may say that it is a sine Fourier series. So don't confuse them. So this is our final answer of the part 1, because they're asking that Fourier series first, then we have to do the sketch diagram here. Okay. Now be careful here. This is a series which is represented now in the form of, it is now represented in the form of what? Sine function, means sine signal. It means that the signal generated by this Fourier series is a stable. It means that we can create a stable signal. So this is our main purpose of learning the Fourier series. But be careful here. Be careful here. If any signal you have generated is exactly sinusoidal, it means that it is 100% accurate signal. But in engineering, we never get 100% accurate sinusoidal. We cannot generate it. Why problem is that? Why we are able to generate this exactly sine? Because the given function f of x is given in 0 to 2/5. We are not doing any adjustment. We are not doing any approximations. The f of x is equal to x is defined in 0 to 2/5 range. So we are not doing any adjustment. We are not doing any approximation. जो है उसका ही आंसर है. So it is the correct one. But in engineering problem, it is not given in exactly range. Then we have to do adjustment. हमें adjust करना पड़ेगा. We have to do the approximation. हमें approximation करना पड़ेगा. But this is not possible without a numerical technique. So in the semester 4, the signal we can generate even the function is not satisfied some of the conditions. Since it is not satisfied some of the condition, the signal produced is becoming approximate signal. Okay, here it is very nice. We don't approximate here. We got finally accurate answer here. Now, so what we did here, step number 1, we calculate the value of A0, AN and BN. Step number 2, we have put the value of A0, AN and BN. Then we have got the answer here. Very clear here. What was the second part of the question was there? And sketch its graph for x is equal to minus 4, 5 to x is equal to minus 4, 5 is equal to positive 4, 5. It means that they are not asking to plot this one, right? Because the range is here 0 to 2/5 only. They are asking to plot this one. They are asking to plot. They are asking to plot this Fourier signal. They are asking to plot this Fourier signal. Now, if I take only these 5 points, I can get this type of graph. Now, how to plot? It is not difficult here. It is not difficult. Just put the value of x here 0. 0 means sine 0, right? G is 0, D is 0. Means the value of the function is here. Suppose this is 5. See, sine 0, this 0, this 0 means what? At x is equal to 0. Don't confuse the left hand side is f of x. Be careful. What is the x? X was f of x. Be careful. The function, this is f of x. It means that it is going to be plotted in the y-axis. What is x? It is f of x. It is given in the equation. If f of x is equal to sine x, it will be sine x. If f of x is equal to x square, this will be x square. But in our question, f of x is x. So we put it the value of f of x is here x. Okay. That's why don't confuse during the graph plotting. This y-axis represent the value of the function f of x. Okay. That's why if I put x is equal to 0 here, sine 0 is 0, sine 0 is 0, 0, 0. It means f of x is here 5. Suppose this is the value of the 5. This is the value of the 5. Okay. Next, put the value of twice 5. What is the value of twice 5? I hope all of us know it. Again, it is coming here 5. If I put, because here twice 5, 4, 5 all become 0, 0. It means that if I put twice 5, I can get the value of the function is again 5. Now put the value of x is 4, 5. Again, all this part is 0. It means f of x is equal to 5. See, at 0 also I have fixed value, which is 5. At twice 5 also it is fixed value twice 5. At 4, 5 also fixed value 5. Now come up from the negative part. Okay, negative part. Minus twice 5, again it is 0. All 0, it means I can get again 5 here. Okay, I can get again 5 here. Now, what was the definition of sinusoidal function? Right? It repeat the values, right, within the complete time period. It means that this solution, whatever you have obtained, the solution, whatever you have obtained, is exactly satisfy the sinusoidal. Now, if I take very discretized value here, if I take here 100 number of points, I can get very smoothly sinusoidal graph. Coming in the previous class graph here, you can get very clear here, like this. Look here. It can be plotted very clear cut like this if I increase the number of points. This is the sinusoidal periodic function. So this format can be possible if I increase. Look here. Here, this point it is negative. It is positive. Here it is 0. Here it is 0. Here it is negative. But here we are not taking all the points. Why? It is not possible to scale by hand by taking thousands number of points. Though they are asking from minus 4, 5 to plus 4, 5. But they are not taking about the intervals. What should be the interval I should take? They are not talking. So any interval you can decide. Interval can be only 5. It can be only twice 5. Whatever it is. So now if I decrease the number of interval, I can get the sinusoidal graph. So this is the case diagram. You can plot it here. Just put the value of sin x is equal to 0. I can get a value of this f of x. Next, just put the value of twice 5. I can get the value of again this f of x. Just put the value of here 4, 5. I can get the value of this. So I can get the value of this, value of this, value of this. Okay. Next questions. If I take it is little bit difficult, then the example number 1 means I am trying to increase now level here. Come up here. Again, be careful that during the plotting of this diagram, you must be very smart at what coordinates the value of sign is positive and negative. First, second, third, and fourth coordinate. What about the cos functions? In which coordinate it is positive and negative, and how it is going to be repeated? Again, we should note that the value of the sine function and cos functions are different at 0 degree, at suppose 45 degree, and it is supposed, because here it is talking about twice phi and phi, means it is talking about suppose 180 degree, they're talking about 360 degree, but instead of this, it may be sometime it may be 30 degree, it may be 45 degree, it may be 60 degree, because we need to plot the sinusoidal periodic functions. So means if I use the Fourier series, output automatically become in terms of sine and cosine. It means it form a sinusoidal graph. So this was our purpose in engineering, that we want to create a signal which is stable. So example number 2 here. What is the difference? Example 1 and example 2. Just read the question here. Given that f of x is equal to x plus x square. In the previous it was only x. Now it is x plus x square, and the value of the x can take minus phi to phi. So be careful here. In the previous example, it was exactly 0 to twice phi. So nothing to do any adjustment. So obviously, the calculation of a naught is little bit difficult as compared to the example number 1, because the function is now x plus x square and limit is from minus phi to plus phi. Okay. Same thing in case of to find out the value of an also, it is little bit difficult as compared to the example number 1. Why? Because in example number 1, it was only x into cos x. I have to do the integration. Now here, instead of this, I have x plus x square. So it is obviously comparatively difficult. If I want to find out again Bn, it is obviously comparatively difficult to find out all these values. Okay, now let us discuss here. First, we have to find out the Fourier series of this given function, x plus x square. Look here, if you are not able to do the integrations, then you are not able to construct the Fourier series. So be careful that if I am not able to do integration, means you are not able to do the Fourier series. That's why please do the integration. I am repeating you number of times. Please do the practice of the integrations. So in example number 2, our part number 1 is we have to construct a signal. Then we have to deduce this one and deduce that this is. Okay. So if part 1 is coming, part 2 will come automatically. So we've done already this one. Look here. Look here. Let x plus x square, again I have written here in the form of series form. Why? Because the second part they're talking about I have to form in this series form. So there is no meaning of putting in the summation form. If only first part they're asking express in the Fourier series, then it is not required to write in a series form. You cannot in a summation form. Now, because ultimately I have to derive, then I should write in the terms of series form, means expanded form. So look here one thing. A naught is equal to 1 by phi. I am writing here minus phi to phi because it is given to you. But I hope that you know the relationship between the integration of 0 to twice phi and minus phi to phi. There is a relationship. I have to multiply either half or I have to multiply by 2. So according to the situations, we have relationship between, if it is minus phi to phi integrations is equal to 0 to twice phi integrations by doing the multiplication by 2 or by doing the multiplication of half. So it is that there's a relationship. So this adjustment is not difficult. Means this also considered as a textbook example. This also considered as a textbook example because it is not difficult. Because there is a relationship by the property of the definite integration, 0 to twice phi can be written in the form of minus phi to phi. Okay, so This was the formula. What is our aim? Our aim is to find our A0. Our aim is to find out A1, A2, A3. Our aim is to find out B1, B2, B3, Bn here. So first, let us try to find out the value of A0 here. What was the formula? 1 by 5. We'll multiply finally the quantity where we can write the equal to -5 to 5 and 0 to twice 5. Not at the beginning level, because in the during the calculation it become confusion. लास्ट आंसर में आप इसको मल्टीप्लाई कर सकते हैं और आप डिवाइड कर सकते हैं as per the situations. Now come up here, write down the formula as it is. But this limit -5 to 5, we know the formula. What was the formula? We have to multiply by twice. If I want to write 0 to twice 5, I have to multiply by twice here. In the final answer, we can multiply here twice. Or at the final answer, we can multiply at the end of the answer. Look here. They put it directly here. Look here. Okay, we'll come it. I think they might forget to multiply, but ultimately I have to do that one. Okay, so here -5 to 5 f of x is equal to 1 by 5 -5 to 5 this one. So I hope all of us can do this integration. X plus x square. So after doing the integration, this is the value of C. This cancel. So it is right. I have 5 twice 5 square. Okay. This cancel. So we can get here twice 5 square by 3 because this 5 is cancelled out. So it is twice 5 square by 3 by here, but they didn't multiply here too, right? We have to do ultimately this one. Next, an. Okay, everywhere we have to multiply by 2, then it can be shifted directly towards the left hand side, because for the A0, as per the property, I have to multiply by 2. In case of an also, I have to multiply by 2, and bn also I have to multiply by 2, because we took here -5 to 5. Okay. So all coefficients are same, so we can take common for all of them. Okay. So next, and how to find out? Just put the formula, and we have to the integrations. So again, it is very lengthy integrations. Okay. It is. I can take this is the first function. I can take this as second functions. First function, second function. If I do the integrations, finally look here. Finally, it is very interesting here. I hope all of you can do all this integration here. Now come up here. This is the very much important things here. See, I assume all the steps you can do the integration by force, you can do the, but final conclusion is important here. Cos minus n phi, because cos is a even function. That's why cos minus n phi can be written cos n phi. Okay, there is no difficulty. After simplification, we can get 1 by 5, 4 phi cos n phi by n square. Now, what is the value of phi? We have to think about this one. The cos 180 degree is -1. Okay, cos 180 degree is -1, means n is equal to 1. So n is equal to 2, 3, 4, 5. How we can write cos n phi? We can write -1 to the power n. So this type of representation I am going to discuss it. Otherwise, I am not going to discuss the integration by parts. I assume that all of you can do the integration by parts. Okay. So now after doing the integration by parts, this is our final the value of an. Cos n phi can be written as 4. This 4 is 4 because this phi cancel out. This cos n phi I can write -1 to the power n. How it can be derived? Because cos 180 is -1. If I take twice, thrice, so it is become -1 to the power n. So n can be now 1, 2, 3, 4 up to infinity. So this is the value of your an. What about the bn? Bn is equal to just put the formula and do the integration by force here. Same thing here. Integration by force by taking first function, second function, or first function, second function as per the islet. As per the islet, you decide it. So after putting here, again I can get here 1 by 5 minus twice 5 by n cos n phi. Cos 180 means cos phi means minus 1. But a cos n phi, it means that minus 1 to the power n. So cos n phi का value क्या है? Minus 1 to the power n. Okay, to the power n. So now the value of a1, a2, a3 can be calculated by putting here n is equal to 1, 2, 3, 4, 5 like this. The value of bn can be calculated here by putting n is equal to 1, 2, 3, 4, 5. So by putting n is equal to 1, I can get a1 and b1. By putting n is equal to 2, I can get b2, a2 from these two relationships. By putting n is equal to 3, I can get a3, b3. Putting all these values in these equations, just put the value of a1, a2, a3, a4, a5. Just put the value of b1, b2, b3, b4, b5 in this series and put the value of n0, we can get this form. This is the value of n a1, a2, a3, a4, and this is the value of b1, b2, b3. And the common from also we can take 2 common here, because a0 during the calculations we have to multiply twice, because I'm going to write minus 5 to 0 to twice 5. Minus 5 to 5 I can write 0 to twice 5 if I multiply by 2. So this will become up here. They might not consider here, but we need to do that. Okay. Now put the value of a0, a1, a2, a3, an. We can get this. Put the value of b1, b2, b3, bn. We can get this value. Okay. So x plus x squared is this one. Here f of x is valid for all value of x between minus phi and phi, but not at the points phi. It is remaining, but not at the end points phi and phi due open interval. इसका मतलब क्या है? This function is valid in between minus phi and phi, but not at the end points phi and phi due open interval. It means that this function is valid only at minus phi to phi, but excluding the phi. I cannot take the phi. Excluding the phi means less than 180 degree. Minus 180 degree up to less than 180 degree. We have to consider it. Okay. Look here. Why it is? Just explain here. If I put f of minus phi, half of, okay, we need to explain this one. Today time is already over here, and we need to discuss some doubts also. So how it is coming, you become confused, and so I need to discuss how it is coming. Okay. So today we stop up to this equation number 2 that we have from our Fourier series. Next, why it is not valid, we'll discuss tomorrow class, and how it is coming we'll discuss tomorrow, because it requires some time. Okay. So time is already over here. Then I'll open for discussion to all of you if you have some doubts. Okay, anyone, any difficulties on today's lecture? You can speak now.
No, sir.
See,
No, sir.
again, my recommendation is that please do the practice of the integration. Hence, we can solve all the Fourier series. I hope you observe that. बाकी सब integration ही है, कुछ भी नहीं करना है. We have to do the integration, but the second example, last part, we have to discuss little bit. Tomorrow we'll complete it. Once we discuss this one, you can solve all these type of problems. Okay.
Okay, sir.
Okay.
Sir.
So. Okay.
Sir.
Yes, please tell me.
Sir, वो